partition, log, replica set, offset, all those things. Fine. So I opened the IDE where we have created the scripts yesterday, like zookeeper, broker 0, broker 1, broker 2, and creating the topic, creating the producer, consumer, and then consumer 2. Fine. Now let's go and then start Kafka Storage Architecture. So in the Kafka Storage Architecture, we'll understand the below concepts. Topics, log files. Topics contains the log files. Log files can be partitioned. Partitions can be replicated on each and every broker. And the replication messages contains these log segments. So we'll discuss about the topics. Logs, partitions, replication factor, segments, offset, and offset index. So very, very important to understand this storage architecture. So what is topic? Yesterday we created one topic, isn't it? So when we created a topic, let me go to the C drive. Kafka. We have the temp directory in that D folder, isn't it? So temp directory, broker 0 logs. We can see the this is the topic with the partition number, right? So what is a topic? A topic is a logical name to group the messages. Like in a database, we must create the table to store the data in the records. In Kafka, to store the messages, we must have to create the topic. So topic is just like a database name. So the topic is the mechanism to categorize the messages. If you are coming from the database world, we can think of the topic as a database table name. So the producer always writes the message to topic and the consumer reads it from the topic. The broker creates a log file for each topic. That means a partition and then replicated log. The broker creates a partition. So this is what the topic name is stock-ticks and 2 here represents the partition. Similarly, broker 1 also have stock-ticks as the name of the topic and then 1 representing the partition. And we can see the broker 2 logs stock-ticks is the topic where 0 is the partition number. So that means what? Topic is a logical name. Topic is just a name. Topic is just a name in which the partition directories will be created. So if you don't mention any partition, by default, it will take 0 partition. Partition number as 0. So it will take by default partition number as 0. That means what? Topic is just a logical name. Whereas the partition is the physical directory which is going to create for that topic. So however, the broker creates a log file for each topic. So each and every topic contains a log file. So when a producer sends a message, it specifies the topic name. Yes, obviously, yesterday we have written the script. So go to here, producer script. See this. Producer, we will mention the topic name, right? So when the producer produces a message, the producer will mention the topic name. And accordingly, the broker parses the message in the corresponding log file. So when a consumer wants to read the message, they consume the message from the specified topic. So we have the consumer 1 also, and consumer 2 also. Whoever, the consumer should have to mention the topic to consume the message. So from this discussion, what we understood, a topic is a logical name in which the messages are getting stored. The producer produces the messages to a topic. Consumer consumes the messages from the topic. A topic is further divided into partitions and replication factor. So that point we will see now. So when we create a topic in Apache Kafka, we must specify two things: number of partitions, replication factor. That is the reason the topic when we create the topic, here we mention partitions and replication factor. So when we create the topic, we must have to mention the two things. One is partitions, second one is the replication factor. So if we do not provide these parameters, Kafka assumes the default values. That means number of partitions as 0, and then number of partitions as 1, and then the replication factor as 1. By default, it will assume the number of partitions as 1, and then the replication factor is also 1 if we don't mention any of these parameters with the command to create the Kafka topic. Okay, so if we do not provide these parameters, Kafka assume the default values, but every topic must have some value for these two parameters. So Kafka assumes default values as number of partitions as 1, and replication factor as also 1. So it will assume by default as number of partitions as 1, and replication factor is also 1. Now you understood about the topic, right? So topic is just a logical name. So what we will do is, let me go here. Let us delete all these things. Right, we deleted. Now what we will do is, again, let us start the zookeeper, right? So again, let us start the zookeeper setup.bat, right? So when zookeeper started, just have the zookeeper data directory. Let's go to the broker one, and in broker one, let's mention, broker 0, let's mention it as broker 0. Now broker 0 is creating a directory here, broker 0 logs, and go to broker 1. Let me clear, and broker 1, let us set up. Finally, go to broker 2 and set up broker 2 as well. Done. So we have done the multi-broker setup or multi-node setup. So all these are created. Now carefully observe. Broker 0 now doesn't contain any topic here. Nothing. Broker 1 doesn't contain anything. Broker 2 doesn't contain anything. Now let us create a topic. This time let us create a topic with the one moment. This is batful, right? Okay. So let us create a topic without mentioning anything. Like, let me just create the topic, but I don't want to mention this partitions and then replication factor. Okay. Now let me go to commands and then run topic create.bat. Sorry, it is trying to creating again 3 partitions, 1 replication factor. We have changed it. Yeah, we changed it.
Sir, maybe not saved.
Saved, na? I saved create bat. Okay, let us see. One moment. Nothing created. Fine. Fine. Yeah, now it is taking, right? So create topic, stack index. Now topic is created. Now let's go here. In the broker 0, we can see stock-ticks-0. In broker 1, we don't have the topic. In broker 2, we don't have the topic. So this is very clear that by default, if we don't give the partition, one partition is taking as by default. And also, if you don't give the replication factor, one replication factor it is taking by default. So what is that replication factor? We'll discuss. Got it? So this is about the topic. I believe now you got it, right? So though we have the 3 brokers, if we don't mention any partition number, replication factor number, it took by default as partition number is 1 and replication factor is 1, and hence the broker 0 got created with the partition. So this is about the topic. So only 4 or 5 points in the topic. What is the first point? Topic is a logical name. Second point, topic, every broker will create the topic. Broker will create the topic to store the messages. Producer will produce the messages to the topic. Consumer will consume the messages from the topic. That's it. And in order to create the topic, we must have to mention the partitions and then replication factors. If we don't mention them, by default, values will be taken. So if we have the 3 brokers, 4 brokers, 100 brokers, but if we don't mention the partition number, it will take partition number as 1, and hence that partition will be created in the broker 0. This is about the topic. Now coming to partitions.
Sir, a partition we can imagine as once we get the data to a topic, it will, if I'm giving a partition 2, so it will be breaking my entire data to store into database like 3 parts, right? 0, 1, 2.
Correct. We have not discussed about it. Just, yeah, that is true. Whatever you are assuming is true. Now let us discuss about the partitions. So just bear with me, because we just discussed about the topic. We have not discussed about the partition, but whatever you are assuming or whatever you are saying is correct. So now let's see. A single topic may store millions of records, but it is not good to store those millions of records in a single topic. And hence, we have to split the single topic into smaller parts. So we have to split the single topic into smaller parts. So for Apache Kafka, a partition is nothing but a physical directory. Now there is a clean separation you need to understand. Topic is a just name, but partition is a directory created inside that broker. Topic is just a name, but partition is the directory, physical directory, which will create inside the broker. That means if we just give the topic name, with the topic name, you don't see the directory here. If we just give the topic name, for it, a partition will be created, and we can see the partitions only as the physical directories in the brokers. So topic is a logical name, partition is a physical directory. So which will divide the topic into smaller parts to share the load across, right? A single topic may store millions of messages, and hence it is not practical to keep all those messages in a single file. Because the consumers who is consuming may get some lag, so we miss the real-time data, right? So that's the reason it is always not good idea to keep all these millions of records or messages in a single log file. So let us divide the log file into a smaller parts. So meaning we will create these log files in the smaller parts directories. They're called as the partitions. So a partition is nothing but a physical directory. Physical directory. Okay. Now just see this diagram. So invoice is just a logical name, but for this invoice, Invoice 0, invoice 1, invoice 2, 3, 4. These are the physical directories created if we mention the partitions as 5. So Apache Kafka creates a separate directory for each topic partition. If we create a topic for invoices and specify 5 partitions, that means Kafka will create 5 directories for the invoice. So the actual log files are stored within these directories as segment files. We will discuss about that. However, now let me again one more time go here. Let me have the zookeeper as is, but at least let me, okay, let us delete the topic. Let me go to our offset tool. So offset tool, yes, no, let us connect. Yes, it is connected. Go to topic. Now let us delete the topic. Of course, we have one command as well. Topic successfully deleted. Refresh. So it may take little time, but topic is successfully deleted. Now go to broker 0. I think this is not affected here. This tool hand. Okay, otherwise I'll do one thing. Let me again stop all these one, like zookeeper, broker, and all. Okay, let me stop. Of course, we have a command to delete the topic as well, but let me stop zookeeper and broker 1 and broker 2 also. Let me stop, and yeah, broker 2 also. Let me stop. Yes. Now let's go back to this temp and then delete everything. Of course, we have a command to delete the topic as well. So, but let me do this. Go here and start zookeeper.pad. Let it start. Go to broker 0. Start broker 0.setup. Go to broker 1. Start broker 1.setup. Go to broker 2. Start broker 2.setup. Done. Now all these brokers were started. So broker 1, broker 2, these are got started. Excellent. So now what we'll do is, let us again create the topic. This time, let us mention the number of partitions as 5. Just let us mention number of partitions as 5. Okay, we are creating a topic and number of partitions as 5. So rather I'm doing this. Let me open. Okay, it's okay. Let me do here. So Kafka-topics, Bootstrap server, create topic, start tips, partitions as 5. Now let me execute this topic.pad. Partitions as 5. Now we have created this broker 0. It don't have any topic or partition. Broker 1 don't have any topic or partition. Broker 2 don't have any topic or partitions. So let us create. Now with the partitions 5, the topic is creating. So that means what? Go to broker 0, statistics 0, statistics 3. These two created here. Broker 1, statistics 1, statistics 2, broker 2, statistics 1, statistics 4. That means what? When we mention the partitions as 5, these partitions were distributed over to the brokers. So partitions 5, right? I'll explain about this partition allocation. There's an important topic called partition allocation. Going forward, I'll explain. But you can see what happened. Each and every broker now have the partitions, right? So broker 2 got 1 and 4 partition. Broker 1 got 1 partition. Broker 0 got again 2 partitions. That means what? when we create a topic with the partitions, then the physical directories were created on the brokers, physical directories, isn't it? Topic never be created as a physical directory. Topic is just a logical name. But when we create a topic, obviously a partition will be created for the topic. So that is called as topic partition. So partition is a physical directory. Topic is a logical name. Okay. So now is it clear between the partitions and then topics, or any questions? Speak out to me. Any questions, or is it clear? Guys, any questions? Is it clear? Someone just now asked the question, right, on topic. Is it clear? Partitions and then topics. Excellent.
So
Yes, sir, it's clear.
Yeah.
5 replicas of topics are created, right? And they are
No, not replica. Don't use the word called replica. We have not used any word called replica. Okay. Replica is little different. So here what is happening is 5 partitions are there, right? Your meaning replicas are okay. Let us not use replica, but let us use what? These 5 topics, meaning the topic name is this one. Partitions are 5, but we have the 3 brokers. Correct. Now what happened? On each and every broker, one partition is created. Then we have two remaining partitions. So those 2 remaining partitions were created again on the available brokers. That means what? Partitions are created on the available brokers. On the available brokers. Got it? Huh? Yeah. Clear, right? Yes.
Sir, what doubt, sir?
Yeah.
Sir, topic is a logical name, right, sir? So
correct.
Still, but still the directory is created. For partitions, we say physical directory is created.
Correct.
Topic also directory got created. And why we are calling it as a logical name?
No. For topic, it was not created a directory. If you don't mention these partitions, so what is the directory created? Stock-tix-0, right? So -0 in the sense what? That is the partition number. So we never seen a physical directory created for the topic. So for each and every topic, a physical directory is creating with the partition number. If you don't mention this partition, it created stock-tix-0 as the directory inside the broker. Again, that is what? Partition. Got it? Huh?
Understood, sir. Thank you, sir.
Yes. Great. Fine. Now we understood the concept of topic.
So
we
one
understood.
So when you're saying if you're not giving any partition, so it will create a directory with name 0, right?
Correct. That means
So-
partition number 1.
Okay. So each and every a broker will have partition, directory 0.
No, it don't have. That is what I have shown. Okay, so probably we'll do this exercise one more time. That is what I have said. Only one. If we don't mention explicitly the partition's number, okay, it will take only the partition as 1. So partition 1 meaning it will go and then sit on the either of the available broker.
Okay.
But only one broker.
Okay, one broker with that means all data is saved into one broker. Means
One broker, correct.
past to, so now suppose 100 records are there. The 100 records will be saved into only one broker.
Exactly. So
If-
one broke.
If 5 partition will be there, they are divided into 20.
Correct.
And according to that, it will be assigned to any of the broker. Maybe one broker get two partitions, right?
Correct. That is exactly true. That is how it will work. Perfect. Correct. Because though a partition have capable of storing millions of records, it is practically not good to store all the millions of records in a single partition because consumer will get the lag in consuming the records. So hence, to speed up the process and to have the real-time data continuously, we will divide it into the number of partitions. Makes sense, right? All of you got it, I believe.
Sir,
Mm.
sir, one question, sir. Sir, here we have three brokers, but we have mentioned 5 partitions. Then how it is managing? Means which broker, where means here we have also right one broker contains 2 partitions.
Correct, correct.
So internally, how it is managing?
Okay, so there actually we will have a topic called partition allocation. So that partition allocation topic I'll explain. So we have a partition allocation topic in the Kafka cluster. Once this storage architecture is done, then Kafka cluster architecture we will see. At that moment, how these partitions will be allocated is what we will see. So, however, we will see in just a moment of time. There is a leader partition and there is a follower partitions. Give me a moment. It will be, I'll explain just maybe in the next, here we got. So I'll explain it in the just, in replication factor, I'll explain what it is and all, how it is created and all. Okay. So I'll explain.
Sir, one question, sir. Sir,
Yes.
if we don't give any value while creation the partition, so the default value for the partition and the replication factor is 1.
Correct.
But here we provided the partition as 5 and
Correct.
not giving the replication. So it's 1 for the replication factor, the default value.
Replication factor is 1 because one message will go to all the partitions.
Okay, sir. Thank you.
Replication factor is a copy of the message that should be available on all the brokers.
Means it's a clone of that partition.
Correct. Duplication is correct. Exactly. Okay, great. Now we understood the difference between the topic and then partition clearly, but only one thing, don't confuse. Topic is a logical name. We never seen a physical directory for the topic inside the broker. Even though the partition number was not mentioned, it will take the partition number as 0 and then will create a physical directory. So partitions are the physical directories, whereas the topic is just a logical name for those partitions. Excellent. Now it is clear for all of us. Now let's go to understand the replication factor. So important. Yeah.
Sir,
Any questions?
I'm giving 500 numbers from 100 to 1 to 500 in 5 partitions. So
1 minute. What are those 1 to 100? They are messages, correct?
Messages are suppose just a numbers, assume the producer. So if I have given 5 partitions, so
Correct.
200 it will be stored in one topic with partition 1, 0 or anything like that. From per part for topic partition with 100 to 200 and next one 200 to 300. So it will be every time in partitions it will be data will be different, right? Not will be a duplicate, right?
Correct. 100%. That is what segmented. So we'll discuss about the segment in this storage architecture only. We have the topic called log segment. So segments, next concept is segments. So here we will get the clarity, but yes, whatever you said is right. Correct.
From consumer, if I want to consume, only I need to give just the topic name, not the partitions and all, right?
That's it. Just topic name. That's it.
Okay.
No
Internally,
partition.
it will pick the values from all the partitions and it will club it.
Correct. So it will use the offset indexes to retrieve the value. Again, that is also we will see how it will retrieve. Offset indexes it will use. Fine. Okay. So let us go.
Just a small confusion I have. So as we can create a number of partitions of one topic. So if we are creating multiple topics, then can we do partition for that topic as well?
Obviously, every topic have the partitions because topic is just a logical name. The messages coming to the topic should have to be stored in the physical directories. So 100%, if you have the multiple topics, each and every topic also can have the partitions, should have the partitions actually. If no partitions were mentioned, at least 0th partition will be there.
Yes.
Got it? Yeah. Yes. Okay. So here, each partition is an ordered immutable sequence of records. So this theory, maybe each record is assigned a sequential number called offset. So this we will discuss going forward, but you will confuse if I discuss this theory now. So let me straightforward go to replication factor. So we understood what is topic, what is partition, difference between topic and then partition. Now let us go to the replication factor. So the replication factor specifies how many copies do we want to maintain for each partition. Confused, right? Okay, don't worry. So the replication factor specifies how many copies do we want to maintain for each partition. I'll explain. So the purpose of keeping multiple copies of the partition is to provide the fault tolerance, right? Same message will be duplicated in each and every partition. If we mention the replication factor, the number whatever we are mentioning, the number of copies of a message will be stored in each and every partition. So if the broker 1 dies, its data is still available on the broker 0. The broker 0 dies, the same data will be available on the broker 1 and the broker 2 as well. So fault tolerance is easily achieved. I mean, fault tolerance in the sense, if something went wrong, then get the same data from the alternate system, isn't it? So that is, for that, the reason we will use the replication factor to achieve the fault tolerance. So the replication factor multiplies to the number of partitions. So for example, we given the number of partitions as 5 and replication factor as 3. Then what will happen? 5 partitions will be created, and on each and every partition, 3 copies of the message will be stored. So 5 partitions we have, each partition have 3 copies of the message, then 5 into 3, total 15 messages. So in this case, Kafka should create 15 directories. 15 directories. So the calculation is simple. We wanted to produce 5 partitions and maintain 3 copies of each partition. Sorry guys, here replication factor will be a copy of each partition. Copy of each partition. So, and that makes 15 directories. So we term these directories as a partition replica. So here it is. Let us create this ones. Exactly same we will create. So I stopped everything. Zookeeper stopped, broker 0 stopped, broker 1 stopped. Now it's time. Let me go here and then delete all the directories. Yes, those got deleted. Now go to Zookeeper and then start Zookeeper setup. Let it start. Now go to broker and start the broker 0 setup. Now started. Now let's go to broker 1 and let's go to broker 2. Perfect. Now we restarted.
Sir, it means actually replication is the multiple copy of partitions, and it stores in multiple brokers. If 0 broker have 3 partition, and replication factor also have 2 replication. So 0th broker 3 partitions, that 2 replications is divided by 3 partitions.
Exactly.
It's there randomly, not we can specify this partition have this replication. So internally it manage as per their algorithm, right?
Correct. So each and every partition has been duplicated. So that is what the replication factor. So let us see -- partitions is equal to 5. And then let us also give -- replication factor is equal to, let us give 3. Replication factor is equal to 3. So let us give this one and let us save this. Yeah, I saved it. Now go to topic. So right now, carefully observe because this is little confusing point. So broker 0 doesn't contains any partition. Broker 1 doesn't contains any partition. Broker 2 doesn't contains any partition. Okay. Now let us give 5 partitions. That means 5 partitions are created on 3 brokers. And then we are asking to maintain a copy of the partitions on each and every broker. 3 copies. We can ask even 4 copies, 5 copies. Okay. However, let me first.
Sir, replication factor is equal to 3, sir.
That I'll Correct. 3 I have given. Replication factor is equal to 3.
So at least a zero partition should be there, na? So broker 1, broker 2, and broker 3. Zero partition should be there, na?
Correct. 0 partition will be there. That's true.
Sir, equal is missing, sir. After replication factor, space is there.
Yeah, sir. That's why I'm telling.
Okay. Replication factor is equal to 3. That's okay. Is equal to we can give, and then space also we can give. So that's fine. Anything is fine. That's okay. Yeah, thanks a lot. So now let us see. This is what topic create. So topic create dot pattern. Yes, now the topic is created. Now assume broker 0, see this. What happened? 2 topics are created, but a replica of other topics are also, 2 partitions are created, whereas the replica of other partitions also came here.
No, sir. The 0 to 4 is the partitions, no, sir, total. And replicas is the inside of that partitions, I think. Correct.
What I'm saying is 0 and then 1 might be created here. Correct? 2 and then 3 might be created in another broker. 4 might be created in another broker. Isn't it? So those got replicated here as well. That's what I'm saying.
Sir, you just assume this, na? Ki 0 or 1 will be created in this and other are the copies. Right? You
That's
just
what I'm
assuming it.
saying. Correct. That's what. So 0 and 1 may be created in this broker. 2 and 3 may be created on another broker. 4 may be created on the third broker. But what happened? As the replication factor 3 we mentioned, right? 3 copies of each and every partition is available here. So that means what? On broker 0, whatever the partition created, this is available in 2 others also, because this is 1 number and we can go here 2 number, we can go here 3 number. So 3 copies of the partitions are there. Similarly, maybe broker 2 got created with the sticks 1. So this is the number 1 partition, number 2, and then number 3, like this. So let us understand this with this diagram very carefully. So we can classify those 15 directories in 2 categories. One is leader partitions, second one is follower partitions.
Sir, actually, as per the partition and replication names, so we cannot differentiate in the directory names. So how we can understand? So that is the replication and one of the directory, and one of the directory is the partition.
Let me first complete the topic now. So first I have to complete the topic in order to answer these questions, isn't it? So ask your questions. What is happening? You know, what I am now explaining, you guys are asking that question before only. So with this one, actually, it will be like mumbling will be happened. So look at whatever I'm saying, ask your question once after I'm done. Then 100% I'll answer your questions. You only can answer that, but I'll answer it. Okay, just give me 1 or 2 minutes to complete this one. Okay, so we can classify those 15 directories into 2 categories. One is the leaders, second one is the followers. So what will happen? We mentioned partitions as 5, right? So partitions as 5 meaning *ticks with this topic name. 5 partitions will first create on the available brokers. So those are all called as the leader partitions. These are all called as the leader partitions. That means what? While creating the topic, we specified the number of partitions as 5, and Kafka creates 5 directories. These 5 directories are called leader partitions because we mentioned that with the partitions is equal to 5. So they will have some name, right? So maybe they will have some name as *ticks 01, and here maybe *ticks 2 and 3, and maybe *ticks 4. Now what we are asking? We are asking it to duplicate or create a replica of each and every partition. Again, duplicate each and every partition that has created to a 3 copies. So that means this, again, these partitions, leader partitions, invoice 0 is there, right? For this one, on the other brokers, same directory will be created because It is the copy. Replica factor is a copy of the partition. So same to same with its name, it will be copied to broker 1, broker 2. Assume there is invoice 1 partition created on the broker 1. This is 1. Then invoice 1 and invoice 2 are created on broker 0 and broker 2. Assume invoice 2 is the leader partition created on the broker 2. So it is already created. 1 is gone. Remaining 2, because we mentioned replication factor as 3. So 1 is this one. The remaining 2. So with the same copy, same name, it will create one directory on the broker 0 and it will create another directory on the broker 1. So like that, it will create the leader partitions and follower partitions. So whatever the partitions is equal to 5 we gave, this the directories will create, right? First 5 partitions will create, right? So these are called leader. Then we mentioned replication factor. That means create a copy of these partitions on all other brokers as well. So that's the reason now on the broker 0, statics 0 partition created. On broker 1, same statics 0 and broker 2, statics 0 directory will be created because it's a copy. Replication factor is mentioning a copy of the leader partition on the other brokers. Now got it? Any questions? Now got it? How it will be happen? Clear or any questions here? Someone asked the same question. Now is it clear?
No, sir. Actually, in the directory structure, I'm not understand the name of the partitions and replication. So I see that all the names are replication and partition are the same.
Correct. Why? Because what is the replication? Copy.
It's a copy. But how we how we differentiate that folder is the replication folder or
no, there is
another folder?
No, we don't have such a segregation. We don't have such a segregation because that is the copy. See this, every original, meaning these are all partitions actually. There is no classification. These are all partitions. All are partitions. There is no separate classification like this is replicated partition, this is leader partition. No, there is no separate segregation. All are partitions in simple.
Sir, if in case I have created 5 partitions, it's a leader partition and replication also I mentioned 5 for
Correct.
each partition.
Correct.
So after some days, I found there is the lots of partitions and followers are created. So I want to delete 2 replication for that partition. So how I can delete those 2 only replications followers? So
Okay.
I'm not understand that.
Okay, so we have to downgrade it. So for example, now we said create, right? So Kafka-topics. Now let's go to the command prompt. Let's ask the Kafka-topics. Just let's Kafka-topics. Okay, I don't see any help here. 1 minute. Just let me go here. Here, bin, Windows. Now let me Kafka-topics .bat -help. Let us see the commands. Now, let's go here. Okay, so we can describe this and then we can mention alter the number of partitions, replica segments, and our configuration for the topic. So we can use this alter option. Okay, so how we can use that alter option? Let us see this. Now we have created the topic, right? So that means now let us use -alter. Let us get more help for this alter. So we want to now alter it. Seems to be it is not given a help for this -alter, but yes, we can alter it. So let's say here we have taken this create, right? Just mention it to alter. For example, I want to alter maybe 2 copies only. So if we just give alter -alter, that means we are in the topic, right? So topic create.bat.
Sir, alter is for a partition or replication?
Alter is for altering the number of partitions, replica segments as well. Okay. Yeah. So I think we can do this exercise maybe going forward, but yes, if we do just mention the partitions as maybe 4, then it will alter accordingly, and partitions maybe 2, it will alter accordingly. So alter is the command, it is available for us. So yeah, you can also do this exercise, or we can also do this exercise. Okay, so but let us go with the topic once. If you do such an exercise, maybe the deviations will come, but your question is 100% valid question. So we have the option called alter, so we can use that alter and then alter it. So let us do it if required, maybe end of this discussion. Okay, right.
Sir, can you please show us the broker 0 and broker 1 folder as well?
Okay, so D, temp, broker 0, broker 1, and then broker 2. Yeah.
Like 5 copies are present in each 3 brokers block, correct?
5 partitions, correct. So number of partitions as 5, replication factor is 3. So we have the 3 brokers available, and each and every broker, those 5 partitions are duplicated or replicated with each other. Make sense? Now here is the biggest question. Sir, 3 brokers are there. You have given replication factor as 3. Good. If I give more than that, for example, 5, then what will happen? So let us do that exercise. Just give me a moment. Getting my point, right? So 3 brokers are available. So it created on 3 brokers. So let me go to this one. Broker 1. And let me stop the zookeeper. Okay, before that, always you first stop the brokers and then finally stop the zookeeper. Okay, so that is always the good option. One moment, let me stop it. See, the brokers are sometimes not responding. Sorry. Okay, now go to broker 2. Please get terminated. Give me a moment. Pressing Control C, but it is not hearing. It is trying to connect to the zookeeper. Pressing Control C, but it is not listening. It is trying to talking to zookeeper. So maybe after some time it will be come back, and then it will stop. Okay, let us wait. Oh.
So you can click on cross icon also for that. Yeah, remove right side delete. Yes.
No, it will delete this.
Correct.
This again we have to click.
That's window is deleted, but you can again execute new window. New tab.
Correct. I have to take one more
Correct.
command prompt, and then yeah, that's true. That is there. Let us see whether it may be stop or not. There is no zookeeper. Why it is not suspending? Yeah, let us do that otherwise. So go to command prompt and cd space commands, and let us rename it as broker 2. Okay, now done. So Zookeeper is now stopped. Broker 0 stopped. Broker 1 stopped. Broker 2 stopped. So better first stop all the brokers and then stop the Zookeeper. That's the good way. So Zookeeper again I'm starting. And broker 0 I'm starting. And oh my bad. We have to delete the directories, right? So my bad. Yes. Okay. So let us delete these directories. Perfect. Now done. So now let's go to Zookeeper and then stop it. Start the Zookeeper. Let's wait till the Zookeeper will start. Yes. So go to broker 1. Sorry, broker 0 and go to broker 1 and go to broker 2. Perfect. Now all the brokers are started. Right. Okay. Now what is the use case that we are trying to do? 5 partitions only. So let me give more than 3 replication factors. So how it will be is what we thought of seeing. So no partitions here, no partitions here. Okay. Now what I'll do is let me give the replication factor is also as 5. Okay. Now let's see what will happen. Go to create topic. Okay. So replication factor is also 5. That means first 5 partitions will be created and they are trying to replicate on the available brokers. Each and every partition 5 times trying to replicate on the available brokers. Here we will get one problem actually. Seems to be, but let us try. Because on the broker 1, one set of 5 partitions created. Broker 2, one set of 5 partitions created. Broker 3, one set of 5 partitions created. And again, if it's trying to create again broker 1, it will give us the problem because the directories were already existed. But let us see in this case what will happen. So let's see. Topic created pattern. What happened?
Sir, mention create, sir, not alter.
That's true. Thanks a lot. Yes. Create, yes. Okay. Fine. So broker 0, yes, we don't. Broker 1, no. Broker 2, no. Excellent. Now let us topic created pattern. Now see. So replication factor 5 larger than available brokers 3. So error, invalid replication factor exception. Replication factor 5 larger than available brokers. So by this discussion, what we can understand, always the replication factor is equal to available brokers count. Then only it will be able to successfully duplicate the leader partitions onto the other brokers. Got it? So this is clear, right? So let us note it down somewhere in our notes. So scroll down. Okay. Okay. So while creating the topic, we specified the number of partitions as 5 and Kafka creates 5 directories. These 5 directories are called as leader partitions. So the leaders are created first. Yes. Then we also specified the replication factor as 3. That means Kafka should ensure 3 copies for each of these 5 partitions. One is already there in the leader. Hence, Kafka creates 2 more directories for each leader. 2 more directories for each broker. Let me mention 2 more directories for each broker. And we call these copies as followers. So remember, followers are duplicate copies of the leader partition. Followers are duplicate copies of the leader partitions. So the leader partitions are followed by the several followers. The number of follower partition depends on the replication factor. Okay, note, since the partition replica is a directory, it cannot grow beyond the capacity of the disk or the mount point. So the maximum size of the partition is limited by the space available on the machine on where we are executing. This is one node point. And second node point is the replication factor. The replication factor number should be less than or equals to the number of brokers. Otherwise, the replication won't be happen and will end up with the following error. Okay, so this is the second node point. So we are
Sir,
now trying.
Can we
Wow.
run again with number of replication as 2? Then what will happen?
Let us run. So let us take this error highlighted. Error while executing the command replication factor 5 larger than available brokers. So this is, let me take it. Right. Okay.
They will start brokers, na?
Which one?
Available broker means started broker, na?
Started brokers, correct. Started brokers. What are all started and then connected to the zookeeper. That's true. Okay, now broker 0, no partition created. Broker 1, no partition created. Broker 2, no partition created. So if we give the replication factor as only 2, okay, it is less than the number of available partitions. So just let me save it. Now we have given only 2. Now it will create without any issues. Obviously, it created. So how it created? First 5 partitions it will create. Then what it do? Again, create a copy of these 5 partitions. So broker 0. Now see, 5 partitions. First, let us say statics 0 or statics 1. These are all leader partitions. And maybe this is leader partitions. Maybe this is leader partitions. So let us try to understand this. Assume broker 0 created statics 0, statics 1. Assume. Broker 2 created statics 2 as the leader partition. Then broker 2 also got the statics 0, which is created in the broker 0. Now go to broker 2. Let's say broker 2 got the statics 3, statics 4 are the leader partitions. It also got statics 1 and then statics 2. So what is happening? The statics 1 here is not on the broker 1. Again, the statics 1 on the broker 0. So this, as the replication factor is less than the number of available brokers, then the zookeeper is easily able to maintain these duplicate copies of these partitions on each broker, right? So it is possible, no issues. But if it is more than the available brokers, it will be the problem. So got it? Any questions here about the replication factor?
So what is the best practice in the real time?
Yeah, now replication factor is equal to number of available brokers. That is the best practice. Let us also type it here. So one more point. Yeah, thanks. So this is, we will write. So the best industry practice is to have the replication factor number is equal to number of available brokers. Available meaning started and then connected to the zookeeper. Those brokers. Number of available brokers. So replication factor is equal to number of available brokers. So this is the best industry practice. Perfect. Right? So we are good, I believe. Now let's go to segment. So before going to the segment, let us take just 5 minutes of the break. Okay, because continuously we are taking, right? So just 5 minutes break, let us take and then come back. So here, this is we completed. Now let us see about the segment. Let us see this offset as well, but just we'll take 5 minutes break. Break for 5 minutes. Okay, we'll gather by break for 5 minutes and then we'll be back by, now it is 9:10. So around 9:13 a.m. IST, I'll be back. So I'm muting myself and okay, again, let me re-explain this. So segment is what actually? Segment is indicating rather than storing a messages in a single log file, the messages can be split over into the many log files. The Kafka log file is split into smaller files known as segments. So how it will split and how it will maintain, let us see it now. So if we look inside the partition directories, we will see a bunch of segment files. So what we will do now, let me stop these brokers. One moment, guys. One moment. I'm just starting the Jupyter. Just a minute. Let me stop this broker 2. Let me stop this broker 1. Yes, let me stop this broker 0. Yes, I stopped it. Broker 1. Yes, I want to stop it. The best practice is first stop the brokers, then stop the zookeeper. That is a good practice. Otherwise, we'll end up with the error in stopping those brokers. Now, let us delete this. What happened? What happened? What happened? Okay, fine. Because here open the directory, that's the reason. However, now let us start the zookeeper. So before starting the zookeeper, what we will do is, let me open the IntelliJ IDE. Here we loaded our Kafka directory, isn't it? So let me just, yeah. So in the config, close server.properties, right? We will have the size of the, one moment, size of the log segment. Let me go to zookeeper.properties properties. This is just where to store and all. Okay, fine. So server.properties contains the log segment size. Yes, you can see it here.
112, sir. Yeah.
Yeah, this is. So the maximum size of a log segment file is this one. When the size is reached, a new log segment will be created. So that means here you can see when the partition receives its first message, it creates a segment file and stores the messages in that segment. The next message also goes to the same segment. Third message also goes to the same segment until the segment file continues to grow its maximum segment limit. The maximum segment size is either 1 GB of data or a week of data, because we said the messages will be saved in the broker for a week. So either it is reaching the maximum segment size as 1 GB or it is reaching the 1 week of data. So to understand the segments, what we will do is, let us reduce this 1 GB to 1 MB. Let us reduce this 1 GB to 1 MB, or maybe 10 MB, or just 1 MB, we will see. So we have a data, right? So go to here, we have a data. Maybe this is in KBs as well. One moment. Let me go here. Let me go here. Apache Kafka data. This one. Okay. So now what we will do is, let us first now take the size of the log segment to only just 1 MB or just 2 MB, like that. So how we will change it? 10777. I think this is the number of bytes, right?
Yes, sir. That is the 10 MB.
Correct, correct. So now we need to take the okay, go to online, bytes to GB. So 1 GB. So for example, if we do reverse way, here let's take the MB. Sorry, my bad, MB2. I mean to say MB2. Megabyte to byte. 1 MB. What is this number? 1 plus E6. Okay, go back. One moment. Bytes to GB. So let me reduce this. Let me keep it megabyte. 1024 megabytes. Okay. Now let us reach it. 102 megabytes. 10 megabytes. 1 megabyte. 0 megabyte. So let us keep 1 megabyte. Fine. So let us keep this one. So this log segment file size, if we don't mention, by default it will take us.
Sir, this is not the actual file. Actual file is broker0.properties.
Correct. So go to broker0.properties. Let's close other tabs. Scroll down to segment. Yes. So take a property. Log.segment size is till this 41. 1073741. That means 1 MB. Then copy this property. Go to broker1. Scroll down. This is this one. Go to broker2. Scroll down. Let us reduce this. Excellent. Now all three brokers properties file now changed to have the just 1 MB of the data. Okay, just to make it simple and then understand, let us take only one partition, because I want to first give the clarity on how the messages are going to be stored in the segments. That is what I would like to give the clarity first. Okay, so now let's go here. Start the zookeeper. Yes, and did we remove the directories? Go to D, temp directory. Yes, we remove the directories. Now start the zookeeper. Now start the broker0. Start the broker 1. Start the broker 2. Done. Done. Let them start. Now Zookeeper started, broker 0 started, broker 1 started, broker 2 also started. Now go to create producer. What we will do is, let us create without mentioning this number of partitions, just to understand the concept first. Okay, sorry. Sorry, just let me take here as 3. So to understand the concept. Okay, now let us create topic. Now only one partition will be created. Just to understand that things, I'm just doing this. Now not in the broker 0, not in the broker 1. In the broker 2, only one partition is created. Now inside this partition, we have only one log file. Now when this log file will reach us the 1 MB, then the new log file will be created. New segment, new log file will be created. So now let's go to the producer and let's call producer.bat. Now let's see this. No, we don't see here. We don't see here. Here only we have to see, but the data we sent is just minimum KBs, right? It's not in MBs.
So maybe segment value we mentioned is a very low, 1 MB. So blocks are more than 1 MB.
No. Then new file should have to be created, right? That is the expectation. New segment file should have to be created. That is the expectation. One moment, just give me a minute. Let me plug in my charger. Just leave a moment. Fine. So whatever the data that we supplied is not even 1 MB. So what it will do, the default maximum size limit when reaches the 1 MB of data in our case, then it will create a new segment file. So number of segment files we have to see. So what we will do now is, there are no segment files. Let me keep on send the data. Let me keep on send the data. Though it is duplicate, let me keep on send the data. We are creating the topics, right? Yeah, sending the producer. This is correct. Producer.bat. Yes. Now let's go back. Broker 0, broker 1, broker 2, stack 2. So we even have not seen this one. Maybe it will take little time.
Sir, can we take maximum size as 1 KB?
Correct, that will work. 1 KB or 10 KB, something like that. If we can take, that will work. So we'll do maybe 1 MB of data we are not having. So let me again stop this one. And stop the broker 0. Stop the Zookeeper. I think no need to stop the zookeeper, right? So, but okay, let's stop the zookeeper.
So no need to stop, sir.
No need to stop. That's true.
Yeah.
But that's okay. Let us do. I know no need to start for sure. But let's have the everything as new. Something. We need to do the change, right? So what we will do? Let's go to this one. Let us change here.
1024, sir. KB, 1 KB.
Correct. 1024. That's true. 1 KB kilobyte. Yeah, 1024. Simple. Yeah. So let's give 1024. Broker 1, 1024. Broker 2, 1024. Excellent. Now we have done the changes. So start the zookeeper. Go to broker 1. Start the broker 0. Go to broker 1. Start the broker 1. Go to broker 2 and start the broker 2. Excellent. All these were now started. So no partition yet created because we have not created yet topic yet. Now go to create topic. Create the topic. Yes, topic is now created. Yeah, static 0 is created inside this broker 2 logs. Now let us go to producer and sends the data. Error we got 76 bytes with an error. The request include message batch larger than the configured segment size. That's okay. 1 minute, guys. The request included message batch larger than the configured segment size on the server. Okay, so we'll do one thing then. Let us delete the topic and then let us one more time create the topic with the partitions, because the data that is writing into a single file is very large compared to the notation what we have given. Right, 1 KB we given, but we are writing more than that. So to solve that problem, let us divide it to the partition so that in the partition the data will be segregated, but more number of segment files will be created. So let us do that. In order to do that, let us delete the topic first. So Kafka -topics, delete, and then the topic name is, let us check this -help. Seems to be, yesterday we did set up the path, right? That path is resetted. Seems to be okay. However, now Kafka -topics that back -help. So we already have that handout to delete topic and all, but let us take the help to delete the topic. Yes, -delete. So what we can do now, let us delete it. So Kafka -topics -delete stock -ticks. I think I gave wrong. Broker must be specified. So let's use this one. Rather this create, let's mention delete. That's it. Now the topic has been deleted. So go here, go to our D directory, temp1, broker 2. Still the partition is there. Topic is deleted, but still the partition is there. So that is one of the problem actually. Let me delete this partition directory. because there is no topic, right? We can delete it. Excellent. Now what we will go to our topic here, and let us create it with the partitions. So partitions are, let's give 3 partitions. Each and every partition contains one copy of the data. So this is one thing. Save. Now let me try to create the producer. Sorry, try to create the topic. So create topic. Now 3 partitions. Error is marked for deletion, while topic is marked for deletion. Okay. Okay, folks, let me stop all these things without having these errors. Yeah. And let me stop this as well. And again, let us read it. So about this Kafka topics, comments and all, we'll have a separate session on that. Just comments, right? So concept is important for us now. So now what I'll do, let me also stop this zookeeper and remove everything here. Yeah. Now let us start. Zookeeper start. Broker 0. Broker 1 setup. Broker 2 setup. Excellent. Now all these got done. Broker 1, broker 2, all this got created. Now go to topic. So let us create the topic with the replication factor as 1 and then partitions as 3. That means each and every broker contains the 3, meaning first of all, these leader partitions will be created. Each and every broker contains one partition. Again, the same partition has been duplicated on the other 2 nodes. So that is what we gave here. Yes. Now go here. Statics 2 and statics 1 and statics 0. Right? So we have given the replication factor as 1. If replication factor as 3, then this would have create here 1 and 2 might also come, correct? So, but we given only 1 replication factor. So each and every topic is partition created. That is only within the broker only. It won't be copied because replication factor we mentioned 1, which is the default one, isn't it? Now let us go and then produce the data. Still we got the issue. The request included message batch larger than the configured segment size of the server.
Sir, we can increase to 50 KB.
50 KB
100
or
KB.
100 KB let us do, because our data is around 160 KB, I believe. 168 KB. So let us increase it to 100 KB and let us try.
So ideally, if it is 160 KB, it should create 168 segments in one topic.
Not 168 segment. One segment file contains. Okay. Before doing this exercise, let us understand the concept first. Okay. Fine. So what it will do, how it will store. So this is one segment. So basically one log file will be created. One segment file will be created like this, segment 000. In this segment, the messages will be stored with the offsets. So, okay, let us continue the topic actually. So where we stopped, we have stopped this, how the messages will be stored into this segment. So segment nothing but a log file, 0.1. This is one log file. This is one log file, 0.1. Log file contains messages. Messages will be identified with the indexes. So offset. Every Kafka message within a single partition is uniquely identified by the offset. So every message storing into the segment. Segment nothing but a log file. In that log file, the messages will be stored with the offset. See this. This is offset 001, 00, 002. These are all offsets. So now the segment size is what? 100 KB. So 100 KB of the messages will be stored in this segment file. With each and every message is identified with the offset. After it reaches the 100 offsets, meaning the size of the segment is 100 KB, then one more segment file will be created, which will start storing the messages from 101 to 168, because our log file size is, our messages are 168, but the segment size is 100 KB. So remaining 68 KBs of the data will create here. Correct? So for example, here 100, we have total of 1907 messages. Maybe 12, 1300 or maybe 800 will be create here. Next 800, 1 to 600, 1600 will be create here. Maybe next log segment will be created, and then the remaining messages will go here. The point is, when the segment file reached, then the new segment will be created. Inside the segment, the messages will be stored with the offset. Got it? Clear, right? How it will create and how it will assign. So that is what we're gonna see in the next chapters. So meaning in the next topics, we have a cluster discussion. In the cluster discussion, we will see how the controller will be elected and how the these offset and then the segments will be created. Actually, what is the question? I didn't understand. The question someone asked is, Amit asked, but how it will divide the messages and assign offset to it? That is the internal mechanism of the Kafka. So here, always these properties you can see. So these properties are what? How the messages should be stored inside a broker, isn't it? So here we mentioned the segment size is 1024. So we mentioned 1024 meaning 1 KB. So what it will do? It will try to create the segment file, right, with the maximum size of 1 KB. The data that is storing here will be reached out, then it will create one more segment. How it internally doing is the job of the zookeeper.
Sir, just one question, sir, here. As you said, sir, once the size is reached, then it will create another segment file, right?
Correct.
So if this is true, sir, then why we are getting this error, sir, that the I mean the producer is sending the message has a size greater than the segment file. It should create new file, no, sir? Then
new file. It should have to create new file. That's true. That's true. That's correct. Actually, we should not get that error because it should have to increase. Meaning, if this is created, this is reached, then many number of the files it should have to create. So that is true. Let us see. Let us see.
Sir, make it 100 KB, sir. 1 KB.
Yeah, we'll make it 100 KB and then we'll see. But
it should not affect any, sir. Even if we are taking it as 1 KB, then also it should increase the size and create the new segments. Na?
But actually, maximum 162 segments only it can create. That is the problem. That is one condition. So 162 segments in a sense where each and every segment contains only 1 KB. So 162 KB data only it is trying to store, whereas we have the 168 data is coming.
Okay. Okay, sir.
Yeah, that's the reason. Okay, so let's start the broker 2 and then.
So do we need to change some property in the producer also?
Not producer. Producer is just producing. Storage is happening where? Inside the brokers only, isn't it? So we need to change the properties in the brokers only because storage is the problem here. Producer can produce any number of data. We can't control the producer. But our storage structure should be able to handle.
Okay.
Yeah.
So, but producer can produce in that much rate basically.
Correct. Producer can produce any millions of records, but our storage should be capable of handling that. So that's where our storage is not capable of handling that. So we are increasing our storage now.
Okay. Sir.
Meaning, am I addressed your question? Are we on the same page?
Yes. Like I thought, like some property need to be changed from the producer side also.
No. Producer continuously will produce the data. We can't control the producer.
Okay.
Yeah. Okay. So let's go to our again broker properties. Here, let us change it to into 10, right? So 1024 into 10 meaning it is 10240. I think 102400 will give us the 100 KB, isn't it? This is bytes actually, right? So the file can save 1000 to 400 in the sense, I believe this is 100 KB.
100 KB only.
100 KB. 100. Correct. So if we can change it something like this, perfectly 100 KB. So let us take it 100 KB. Okay, let us write something like this here. 100 KB is the max of the log segment size. Okay, and fine. See this retention hours. The minimum age of a file to be eligible for deletion due to age is 168 hours, meaning 7 days approximately, not 24 into 7 hours. Yeah, 168 hours is by default. Number of partitions, log directories. That's all. So this is, let us copy, put it onto other two brokers as well. Put it onto other two brokers. Excellent. Now done. We have done the changes. So we deleted already the temp directory. Super. Now this is not required. So go here, start the zookeeper now. Start the broker now. Start the broker 1. Start the broker 2. Okay, we were now started. Okay, now let us create 3 partitions on 3 brokers. Okay, so that means each and every copy of the partition is available on other broker as well, other 2 brokers as well. So let us create a topic then. Now topic is created with the 3 partitions. Yes, starting 0, 1, 2. Maybe it is 0 created, 1 created on broker 1, 2 created on broker 2. It is replicated, right? So that's how we can see each and every copy here and each and every copy here. Excellent. Now let us try to produce the data. Okay. Produced. Now let's see how it produced. Go to broker one. Broker two. Segments are not created. Segments are not created because it shared the size, right? Yeah.
Can you push again some more data? Let's see.
Let us push. Sample 2 also we have. And so now what happened, data is sharing now. So that is the reason it may not reach 100 KB on each and every partition because data is sharing now. Let us see by producing more data. Super. Now let's see. Broker 2 lakhs. Statistics 0. Yeah. You can see now segments are created. Correct? So this is one and this is segment. And this is another segment. This is another segment. Isn't it? Now segments are created. So go to here. Yes, segments are created. Go to here. Now the segments are created. Got it? So now how the segments are created? The segments are nothing but the log files. So this is the log file. Again created a segment and again created a segment. Again created a segment. So segments are now created. So inside the segment, how the data will be stored now? Using offset. So offset each and every data that is there in this segment will be starts with some offset. So we can use the Kafka dump, right? So Kafka dump -logs -files. Let us see 0.log. Kafka dump logs is not recognized. Why?
Sir, go to Windows, sir. Sir, go to Windows.
No. Yesterday we set up the permanent path. Remember? Just yes. Echo Kafka home. Kafka home. Yes. Now let us try this. Not recognizing. Okay. Okay, no problem. No problem. Why this is not recognizing is what we'll see. Okay. Fine. So let me take one terminal here. Command prompt. Okay, fine. So we are on D drive. Let's go to D drive, temp directory. So we have a lot of directories. So let's go to broker 2. Broker 2. Inside the broker 2, let's go to statistics 0 or statistics 1. Statistics 2. Perfect. Now we are here. So let us try now. Kafka -dump -log -files 00 log. Okay, now we can see. So from the base offset 0 to 164 is the last sequence. Right? Similarly, again, again 165 to 328. So this log file contains maximum of 327 records, right? See, this offsets are increasing. Offset value is nothing but the message IDs. Like base offset is 0, then from there 1, 2, 3, something like that, it is increasing. Now this contains what till base offset 824 to meaning base offset 0 to last sequence 327 it is having. Clear, right? Now let us do the same for the uh, 00986. Log file. Now see this. In this also, the base offset is 986. Okay. So here last offset is what? 985. And then from here 986 is started. From 986 to maximum how many? 986 to maximum of last sequence 327. So base offset 1857. Meaning another 900 kind of records created. So last offset 1976. So everywhere, see this base offset is 1815 plus 162. 162 or 166. Total is what now? Total is base offset this one, base sequence, last sequence 327. So 327 messages are stored here in this segment. But these 327 messages are not the duplication of the above one, because it is starting the base offset. What is the last base offset of the first segment? From there it is starting. So meaning this is perfect. So now one segment file is created, which is having the offset till 30652. Then one more segment is creating from the offset. One more segment is creating, and it is storing the messages from the offset. Last base offset is the first base offset to the next segment. So then it is storing the around 166 messages, and again it is going to the next segment. So that's how the segments and then the offsets will be managed. Segment nothing but a copy of the log file. Offset nothing but the message, the index that is given to the message that is storing into each and every segment. Is this clear? Any confusion? Any questions? Any questions or any confusions here?
Sir, did you modify in the server properties or in the broker, each broker, the sizes?
Broker. Each broker properties we modify. Only broker, not server. We changed it to 1000. So what we understood, segment is nothing but. So first, everywhere, when the partition will be created, one log file will be created. Point number 1. Point number 2, when this log file size is reaches to the maximum segment size, then one more segment is created. See, each and everywhere you can see 96 KB, 89 KB, 96 KB. And text document, see 0 KB or maybe. So what is happening here? So each and every file, when it reaches its segment size, that is 100 KB, then the new segment file is created, which is a log file only. Segment is nothing but another log file only, isn't it? Another log file only. And how the segment is storing the data? Segment is storing the data because here the last offset we have now. So based on that last offset, now one more segment is creating by treating the first index is the last offset of it. So what I mean to say is, here the last base offset is 985. Then the next segment is created with a base offset of 986. Then it starts storing the data till it reaches the 100 KB size. So once the 100 KB size has been reached, then it creates one more segment. So whereas the last base offset is what here? 1976. So let us see one more. So one more is 986 is done now. So let us go to the next one. 986 is done, right? So let us go to the next one. 986 is done. So what is next text document? 1977. So just let me copy its name. Now its base offset must be something around 1977 because here it is 1976. Got it? Now how the segments are storing the data is clear. So first of all, have you clear segment and then offset? Then how it is storing the data into the segments with the offsets. Clear, right?
Yes.
Any questions here?
Sir,
How
little
many
bit
segments will be
confusion, sir.
created?
Okay, first let me answer that question. How many segments will be created? So each and every segment size is 100 KB. The data that is producing is maybe 168 KB, meaning maybe 168 KB or 100 because we have given a lots of data. Till the end, till it reaches the data, till the end of the data, the segments will be created. Till the end of the data, maybe 100 GB, 1000 GB, 10 MB, 100 MB. Each and every segment is storing the 100 KB data. So it will create how many 100 KB files are equivalent to 10 MB. Then it will create that those many segment files, meaning segment files, number of segment files is equal to the data size that is coming from the producer. Got it? Huh?
Yes.
Yes. Yeah. Someone asking question?
Sir, suppose if it is 1000 KB we are producing, 1000 divided by, suppose we are specifying 10 KB in the property file, 1000 divided by 10, 100 segments will be created.
100 segments will be created. That's it. That's it. 100 segments will be created. That's true. Yeah.
Yes.
Okay. Any more questions?
So can we identify how many offset will be created within the segment?
We can see this. So base offset is 977. Huh? So go here. The last offset is 2959. So the total offsets created here, I think we have to do some count. Yeah, size is 16303 and producer ID is 4 producer and then 2959. So directly not printing, but we can see just by subtracting 1977 1977 meaning 33 and then 2959. So 33 plus 959 around 992. So 992 offsets are created here. So that is equals to our data size as well. 992 offsets meaning 992 messages are created. So that we can see how many messages created. We can see if we have a consumers, right? So each and every consumer, how they are consuming, we can see how the consumers are consuming the data. I mean, how many they were consumed. So, but here we can see around 990 kind of messages stored here.
Sir,
Got it?
sir, I guess message size will be offset size plus 1.
No. Message size is different. Offset number. Each and every offset.
It is a number of messages actually. I think offset means offset size plus 1. Option number plus 1. Because offset
correct.
start from 0.
0, correct. Offset start from 0. So offset plus 1. That's true. That's true. So if we can take like that, so yeah, that some calculations if we can do, then we can see number of offsets. Offset nothing but what? Simple. Offset nothing but the number of messages. Each and every message size may be different, but offset nothing but the message. Got it right? Hope it is clear. Any more questions?
Sir, what is that count, sir?
Count. Where? Count 164. Okay. So this is what, each and every, so base offset is 2796. And how many files it can store maximum from this base offset? 160, 165, 160 to 163. So how many it has been processed or stored? For example, from the base offset 1977, right? Total 166 messages it stored, and hence we can see the last sequence as 165. So count is how many number of messages that were processed. For example, this is the segment. It's the segment. So this segment may contains, let's say, how many messages, how many from the base offset, how many it stored at a time, how many it processed at a time. Around 165, I believe. 165 it can process at a time. So last sequence is 165. And again increase series 327. That means again 165, it seems to be 166, something like that, because we have to add that 0 as well, right? So 166 plus 166 plus 1. Again here it is storing count as 163. So this count is what? How many messages it is storing starting from this offset. So not in this segment. So segment is filling, how the segment is filling. So let us say this is one row, assume just in case. So in one row, how many messages it got fit? So something like that. We can assume this count number equal to. Any more questions?
Yeah, so looks like from the data, right? The sequence number, if you see the base sequence number and the last sequence number, looks like it is associated with the producers. Because if you see producer ID 3, base number 0 to 165, and then 166 to 327, right? And then we got a new producer, that is producer 4. Again, base sequence number started with 0.
No. 1 minute. So see this. Okay, let us come since beginning. This is our log file, original log file. Okay, so we have only one producer. Base offset is 0. Last offset is 164. That means a total 165 messages were processed to store at a time in this log file.
Right.
Okay. And that is from the producer ID 0. But still the log file size is not filled. Then again it started what is the last sequence, 164. Then 165 is the next base offset. Again it processed 165 messages. Because 164 plus 1 it took here. So here it minus 1. So on and around 165 messages it processed.
Right.
Then a total now 328. The producer ID is still 0. Then like that, now 328, so 329, then 165, around 493, producer 0. So like that, it filled 657 messages. Till here it is done.
Yeah.
Now again, base offset started 658. Then here we got the producer ID 1. This is meaning another thread started. Threads actually, number of threads. Those are all processing the data, but not the number of producers. We should not confuse there. Yeah, that's true. Okay, so that's all, guys. From this storage architecture point of view, only one thing is left. That is the offset index, how we will process. So if you can spend 5 to 10 more minutes of the time, then we can even understand this offset index as well, so that we can close this Kafka storage structure for today. And in the next week, let us see the Kafka cluster architecture. I do remember someone asked me a question yesterday. If one master controller broker down, then what is the situation? Right? So someone asked me a question yesterday. I do remember that questions. So the answer for such kind of cluster management questions and then the concepts we'll discuss in the Kafka cluster architecture, which we'll start on the next Saturday. Okay, so let us now discuss about this offset index first. What is offset index? Now we understood what is offset is, isn't it? We understood what is offset is. Offset is nothing but a message that is storing. Every offset is having some number, offset number. So that is nothing but offset index as well, we can say. But however, see, we now understand that each message in Kafka can be uniquely identified by providing three things: topic name, partition number, and then the message offset. So by giving these three things, we can uniquely identify a message. One moment. Right, so one is the topic name and the partition number and then the message offset. I'll showcase this. Perfect. So what we did here, so we have dumped the logs. So when we dumped the logs, we got this data. So that means the data is storing inside the each and every log. So this log is where? This log is inside the partition. This partition is where? Partition is inside the topic, meaning for every topic, the partition will be created. And hence, we can identify a message with the topic name, and then its partition number, and then its message offset. See here, topic name is tactics, and in the tactics, 2 is the partition. In the 2, this is the message index or message offsets, or we can say segments. Simply, we can say segment files or segments. This will give you the more clarity. So each and every message now will be identified with this one: topic name, partition number, segments, and offsets. Make sense, right? Till here, I believe it is clear. So we were identified a message. Each and every message can be identified using the offset inside the segment file. And the segment file will be created inside the partition. And for every topic, a partition will be created with the partition number. Superb. So if we think in database terms, now we need to identify how the data at the consumer side will be retrieved from these segments. That is now we are trying to understanding. Usually from the database, if we want to retrieve the data, what we will mention, we will write one query. Select a star from invoices where customer name is John. So the customer name John who purchases all his invoices will be displayed. So the unique identification here is the customer name. So if we supply the customer name, then the data we are getting. Similarly, the unique identification does not make a good sense. This kind of the query unique identification, like customer name is John, this unique identification does not good sense for locating the message in case of Kafka. Because in Kafka, the messages are storing with the offset and the offset indexes. So in order to retrieve the data from the Kafka, we need to use the offset indexes. Like in database, it should not be something called column name or uniqueness. No. Of course, uniqueness will be maintained with the offset indexes. So in Kafka, the topic name is like a table name in the database, but partition and offset are just numbers, isn't it? Partition is a number, offset is also the number. So that we can see here. So these are all offsets: base 0, offset 165, offset 494. These are all numbers. And the partitions also numbers, right? So they are not kind of a unique columns or something like that. So in database applications, we may want to access the data on some critical columns, such as invoice number, customer name, customer ID. So this we can't do in the Kafka. However, how we can do in the Kafka? So in the Kafka, the application should reach in Kafka, the consumers will retrieve the data based on the offset indexes. So however, this may not be a problem for a real-time stream processing application. In a stream processing application, the requirement is different. A stream processing application wants to read all the messages in sequence. So let's try to understand with a simple example. Let's assume that we have a stream processing application that computes loyalty points for the customer in real time. So the application should reach the invoice topic and calculate the loyalty points. So while computing the loyalty points, we need customer ID and the amount, but we must read all the events. How does this happen? What in simple terms, let us assume in real time, the invoice need to be calculated. So invoice, in order to calculate, we require the customer ID. So where this customer ID and then the customer details, where this will be? These will be in the Kafka broker. Assume in the segment files, we have the customer information. Then how do we retrieve the customer information? Now see this. This is the application. The application connects to the broker and asks for the messages starting from the offset 00. Then let's assume the broker sends the 10 messages to the application. So now the application got the...
Sir, sorry to... So is there any schedule for any other classes at 10?
No. That was cancelled.
Okay. People are pinging in group. That's okay.
Correct. So it was cancelled. Actually, I asked the team to show one banner. So class cancelled for today because Saga can't be completed in one weekend. So I thought to postpone it at the end of our other 2 workshops in 2 weekends.
Okay.
So there we need to discuss the transaction management in Spring, and we need to discuss the CQRS one more time, and then we need to apply the Saga. In Saga again, we need to apply the this one, fallbacking mechanism, and then the failover transactions. There are a lot of topic is there, so it won't be done in single weekend. My bad, actually. I thought I just discussed this Saga. I don't want to discuss this transaction management in Spring and all, but seems to be don't understand if you don't discuss the prior topics. That is the reason I asked team to cancel it and then put it after our workshops, end of the workshops.
Sir, actually, I want to learn OpenSearch related queries, how to we generate the queries in OpenSearch and how to handle, how to do projects in Spring Boot using OpenSearch. So can we take a class for that course or any workshop? So I need that.
Okay, just ping me in the Telegram channel. I'll see. I'll look into it. I'll guide you.
Okay, sir. Okay, sir.
Yeah.
Thank you.
Okay, so let's come back to our concept. Thanks, Parshram, for remembering me. So let's come back to our concept. So this is a consumer. Okay, consumer requesting the broker for the messages starting from the beginning of set. So here we can see the consumer script. We are asking it from the beginning. That means what? Consumer will ask the broker to give me the messages from the 0th offset. And there is a size, how many records that this broker should have to be give. There is a number. Around it is something like how much data it should have to be sent. That is around 165 or 162. I'll come to that point. But in our example, just to understand, so consumer requested the broker to give me an offset 0 records till 10. Then the broker understands and then sends the 10 messages. Here, please understand one thing. Consumer is requesting the broker to send the messages from the offset 0. Then broker sends 10 messages assume to the consumer. Now consumer received the messages from 0 to 9 offsets, 0 to 9 offsets. Then the application takes few seconds to process these 0 to 9 offset records, and then again asked the broker to give me the records from 10 offset. Then broker given the another 15 messages starting from 10 to 24, broker given. Then consumer processed that 10 to 54. And then consumer will ask the one more set of messages starting from the base offset 25. So this process continues till the application receives all the messages. I mean, the consumer receives all the messages. So the process explained in this example is the typical pattern how a stream processing application would work. In this process, we must have noticed that the consumer application is requesting the messages based on the offset. This is what we need to understand. So we must have noticed in this process that consumer application requesting messages based on the offset. So when the consumer is requesting the producer to give me the messages, it will give the offset. Either from beginning we can give, or we can give a particular offset number as well. If you know any number, we can give. So the consumer can get the messages from that offset number, right? So Kafka allows the consumer to start fetching messages from a given offset number. We can also give the hyphen offset number as well. So this means if a consumer demands for messages beginning at offset 100, the broker must be able to locate the message for offset 100. So to help brokers rapidly find the messages for a given offset, Kafka maintains index of the offsets. This is important, right? So to help the faster searching, for example, consumer asking, I want a offset 100th record. From the offset 100 I want. Then broker required to find out what is the 100th offset is. So to find it out, Kafka maintaining a index of the offsets. So this is what the indexing. So we also can see the indexes. See this index file for one segment. Again, one index file for another segment. Again, one index file for another segment. Every segment contains one index file, right? So
what is the snapshot for that?
Okay, we'll come to that actually. Snapshot file will come to that. First, let me complete it. I'll come to it. So now index file, everything is now meaning everywhere we can see one index file. Every segment is having the index file. Okay. Now the index files are also segmented for easy management, and they're also stored in the partition directory along with the log file segments. So this is the offset index, offset 986, offset 1977, offset 2960, and here the indexes files are helpful to quickly find out the particular offset number. So if we can go and then have a thread dump or log dump for the index, we can see it like this. Offset 328, position, where is the position of this offset 328? Offset 493, what is the position? Offset 457, what is the position? So total, how many offsets are there in this first log file? So go to first log file. So base offset is 0, and then the last offset is 165. So one producer, one thread, if we can see for one thread, the last offset is 495. I think 493 is there, 328 given. So let me just see what is this 328. Where is the 328 is? 328, yeah. So last sequence is 328. That means this is the first one, right? After this, the next index is, it is recording 328. Next index is 493. Next 657. And finally, next is what? 657 plus last sequence, I think still 657. Yeah, 823 and then 985. So till 985 we have here. So 985. 823 last offset. So did you observe what is happening here? So indexes are having first row completed, assume. Then the last index, when the first row will be filled with the offsets, is 328. Its position is 1628. So in the diagram you can see offset is 0, position is 0. Offset is 1, its position starts from the 370. Like that, if you can see, offset is 165, which will be starts from the position 16 to 89 in the index file. So once this row is filled, then keeping the position of the next row. For example, if we asked the 100th record, what it will do? First, it will see offset is 100. So it will check this index file. So offset 100 meaning it will go to this position and then try to retrieve the messages from this segment. Meaning before this segment, before this offset, one more offset is there, na? So base offset. So from here to here, it will give the messages. If anyone requested for the 600, offset is 600, it will go and then check here. So that means it will check in this offset 657. So what is the last 657? So this will be processed. This row will be processed. So like that, the offset index will help to faster searching of the offsets inside the segment file. Hope it is clear, right, for all of you?
Sorry,
That's all right. Yes.
For 600 offset, it will go to that 657 offset, and the position will be changing now, sir, at the time.
No, it will go to this position. Finding out this position, 4886 position. So 486 position, and in this position, what are all the messages are there? It just pulled it. That's it. So from the offset 600. So 657 is the starting base offset for it. So 657 it will go here. And then where is the 600? Something around the 600 falls in between these two. Correct? So it will go to this position, and from there to this position, it will give all the records. 681. Clear, right? Yeah. Offset indexes are clear? Great. Okay, so maximum 493 is in this base offset.
Is this actually help to recover the lost bits? Means lost data?
Not lost data. It is not helping to recover. It is helping to find out quickly if any consumer is asking, I want a message from this offset. For example, consumer is asking, I want a message from 200th offset. Then Kafka, rather than searching for all the segment files, maybe we may have the 1,000 of segment files, isn't it? In our case, we have at least 4 or 5 segment files. Rather searching in all the segment files, what it will do is, it will go and then look at the index files. So the offset requesting by the consumer is in which index? If it is this index, it processes the message from this log file. If it is falling in this index, it processes the message from this file. Got it? Huh? Clear
yes,
or
yes,
not?
Yes.
Now, someone asked me, what is this snapshot? Okay, let's go and then snapshot is a backup copy. So let's go and then take this one. If you can see, snapshot didn't came for our base log message. Snapshot came from the segments only. Now, let me go and then take this snapshot and then paste here. Yeah. So this snapshot is having what? Producer ID 1, producer ID 0. Producer ID produced how many messages? Meaning the thread 0. Thread 0 produced how many messages? Thread 1 produced how many messages to this segment, the segment 986, to this segment. How many records and how those got processed is what given by this snapshot one. So produced thread 1, so thread 0 produced 657. First sequence is 497, 494, last sequence is 657. First sequence is 166, last sequence is 327. So like how it has been processed the messages, the overall picture, it has been taken as a snapshot here. Okay, meaning this each and every segment file is giving a step-by-step approach, right? The snapshot is recording like what is the first sequence, what is the last sequence for the particular thread. Again, what is the first sequence, what is the last sequence, and for a particular thread. That's it. So it is just keeping a snapshot overview of that segment file. Clear, right? I believe clear. Yeah.
Sir, how will the consumer know that the message it wants to consume is at that particular offset?
Okay. Basically, consumer don't know. That is the reason consumers will ask from the beginning.
Okay.
But
okay.
we also have the provision if we want. For example, I don't know, but if I know, I can give the hyphen offset number here. If the offset number will be given, then Kafka will first look for the index of this offset number we gave. And if it will false whatever the index and what is the position of that record, it will give that record directly. So searching will be fast. Indexed searching it will give. Like how the Elasticsearch and all is doing, like how the databases searching is faster using the indexes. Similarly, Kafka also indexing. Yeah.
Sir, question, sir.
Yes.
So, like fault tolerance, you mentioned, sir, in partitions, right? So,
fault tolerance can be achieved using the replication factor. Yes.
Yeah. So, you said like any one of, we have 3 brokers, right, sir? So if any one of the broker is down, like, I mean, is corrupted or whatever maybe, we can pick it from another brokers. Will it there be real-time scenario like situation?
If you can see here, see statics 0 having these index files and statics 1 having this one, whereas the statics 2 having all this one. So on the broker 2, we have the statics which having around 1, 2, 3, 4, 5, 6 segments. Now go to the statics 1, sorry, go to the broker, another broker. Go to statics 2. Here also we have the same 6 segments.
Means like broker 1 down, like there be like situation in real.
Exactly. It may be possible, right? So let's say broker 1, if it is down, the same data of the broker 1 is still available in the broker 2. So the zookeeper will immediately elect one of the broker as the controller node and then start routing or start fetching the messages from that controller node. So assume broker 0 is a controller node. Broker 1, broker 2 are the follower nodes, follower brokers. Let's say broker 2 down. Still broker 0 is a controller. So this controller know who got down. So the controller will do what? When the consumer is asking the message, this controller will have a copy of it, and then the follower broker also have a copy of it. Then the controller will manage to give the data from the either this one or either this one. So that is how it will be doing using 2 algorithms. One is hash-based algorithm. Second one is round-robin algorithm. So we'll discuss these 2 things coming up sessions.
So suppose like all these like brokers or whatever maybe in one machine itself, right, sir?
No, not one machine. In real time, these will be on 3 different machines.
Yeah.
Broker
Because
0 is a
like if it is there in one machine, if the machine is down, then we may not get the messages, right, sir?
That's true. That's true. That is the reason we will distribute them. So in our agenda also, we have one agenda setting these brokers on the multi-node on AWS.
Okay, sir. So yeah, in future we will discuss more, sir, if that is the case.
Correct. Okay, so
Sir, one question, sir. If the leader broker itself becomes down, so then how it will work?
If the leader broker will be down, then zookeeper will elect one of the other brokers as a leader. Okay, for example, if we can go here, let me Kafka topic. One moment, I have this one. One moment. Just give me a moment. Yes, so zookeeper shell is the utility where we can see that one. One moment, I'll explain that. However, we will also see this in our next Kafka architecture topic, meaning now see zookeeper shell. Okay, here, what is the controller? We can ask it. So first, if we just see ls space -l, sorry, ls, one moment, there's a command, ls space slash, so we can see admin, brokers, cluster, config, all zookeeper, all these are all, monitoring by the zookeeper. Now, among this, I want to get what is the controller. See, broker ID 0 is the controller. Among all this, I want to get what is the latest producer ID. So this is a latest producer black and the log directories and all. Now assume broker 0 is down, which is the master, right? So from here it is clearing that it is the master. So the controller is broker ID 0. Now let's go here, stop the broker ID. These concepts we will discuss in the storage cluster architecture. Now come here, again ask for the controller. Now see what happened? Broker ID 1 elected as a controller node, controller broker. Then assume, let us bring back this broker 0. Okay, now broker 0 got back. Now go here. Again type what is controller. Still broker ID 1 only, because it is elected, that's it. So initially broker 0 elected as a controller broker and two other brokers are followers. Assume the broker 0 down. Then zookeeper will elect one of the broker 1, broker 2 as a controller. So let's say broker 1 is elected as a controller. Then broker 0 came back. Now broker 0 becomes a follower, not controller, because controller is already acting here, the broker 1. Got it? Am I answered?
Yes, thank you. Sir, one more question. So, suppose in real time, we generally work with object, JSON object or Java object. So for each JSON object, sir, it consider one message or internally it will be getting split into multiple messages.
Okay, each and every JSON, no matter whether the JSON contains how many records, each and every JSON is one message for our topic. One message.
Okay.
Got it? Yeah. Yes.
Okay. A topic can have many messages.
Obviously, topic can have same concept. Topic can have the partitions. Partitions can have the segments.
Right.
Exactly, same concept. Yeah. Okay. So one and only one topic I left in this Kafka storage structure, that is time index. So this is say simple. You just go through this time index, meaning there is a time index also created. If you can closely observe here in the temp directory, stick to, there is a time index as well. Simple. This time index is just saying, Kafka allows the consumer to start searching the message based on the offset number. However, if anyone want to search based on a timestamp, for example, during this hour, during 9 a.m. to 10 a.m., I want to see all the messages that are produced by the producer. In such cases, time index will help. Kafka uses this time index. That's it. So that's all, guys, from the storage architecture. Then the next week, we will start with the cluster architecture.